So this is a new kind of phone. It's made of blocks. Detachable blocks. They are all connected to the base.
It really worked. It booted, it could make pictures, swap modules out. Super impressive. They put a lot of effort in this thing. But then the company decided to focus more on software. Boom, project gone. Just like that. And I was watching this from the sideline.
What if I brought this back? I can use that S10 I have, and it'd be a good project to do.
This is a fully modular phone concept from Google in 2013. They began to develop it, although it never caught on and it failed, although I'm taking it into my own hands. Now, just before we start, I actually did re-record the Fusion footage as I was using a 1050p monitor and it wouldn't stretch out well, so yeah, it's just re-recorded footage, but it's the same voice. So this is the project I'm just after finishing, and while I do love it, it is a bit simplistic and unergonomic, so I want to make this phone practical and actually usable in day-to-day and be a bit more complicated. And this was my initial design here. Although, as you see, I have to iterate the front design as well with speaker, camera and microphone. Now you may actually be wondering why I'm doing this, and the real reason is because it's really cool. And wouldn't it not be cool to just slap on a random block in the back of your phone and have a laser USB keyboard? I'm not really doing it for the e-waste, as realistically I'd need a full company and a full proper team to do that, so I'm just doing it as something cool to do. So over these past few days I've been keep changing the design and I really got into this. Roughly kind of the shape of a phone, more of a case, but I will actually enclose it with screws just to make it more than a glorified case. Now, I didn't want to do this, but I kind of have to. So for the PCBs, what I decided to do was have a USB hub to connect through the USB, another one to connect to the side HDMI port, as this will have HDMI native, and I also wanted charge, so I wanted a USB splitter down the bottom port. I also want the display and camera to be removable, and maybe even an internal board where you can take it out and put in an N100 board, which can run Windows natively. And I want the camera to be able to be removed just from the original connector, as there's too many pins to realistically model it. I did want to have a side-mounted HDMI port and then get a hinge and kind of make like a Z fold, but I really realised that there wouldn't just be enough space for that, and I really was getting tight on space, so I just kind of scrapped it, and I don't really need it anyway. So for today and the next few days, I actually just want to focus on the PCBs, as I've been doing lots of the 3D modelling, and I need to start the PCBs and the inner workings of it. So what I've done is I've actually made it so there's like around 7 or 8 ports, called the ultimate port, and all blocks will connect into here magnetically using pogo pins from AliExpress, as you can see here on screen. But yeah, this should work hopefully. I've been kind of researching into how to model this. I've been using Easy EDA, which is a really good free online editor. And yeah, it's been working perfectly. It's been going well, and for something this brain power for me, I think it's pretty good. So I'm going to continue doing this and I'll report back whenever I'm finished. Yeah, so I hope this goes well. So as you know, I have scrapped the inner USB-C hub with the HDMI port, as just there's not enough space for how thin I want it to be. And I also want to just start getting on with the project. So what I've done is I have this USB-C cable, splitter down into data and USB, then this USB cable into another USB-C cable into this full board. So here's the rough idea I have for the PCB. It's going to be one USB-C connector into it and an FPC connector into the battery. But for now, I'm going to focus on the USB-C part. So there'll be loads of pins in the back, and I'll buy these little pogo pins off AliExpress. These are just little golden contact pins that have springs mounted on them, so that you can just literally magnetically connect it without a physical friction connector. So there is also going to be hopefully some for the wireless charging modules and others like the speaker, but for now I'm going to focus on the USB. So the USB will be over USB 2 protocols just because USB 3 is unnecessary for this product and I don't need it. So I'm just going to have data minus data plus 5 volts and grounds as you would in USB 2. So I'm going to just have small through-hole components wired into a direct USB-C cable and then all of those wired into copies of itself down on one board. Now, as for the actual 3D model of the case, I do plan to get it made out of aluminium because I was going to initially 3D print it, but I might just, why not? And I did also have to make pretty major changes to the entire phone. I found that the wireless charging coil actually manages the charging circuitry and temperature of the phone, and without it, it doesn't boot. It literally can't boot because it thinks it's overheating. And I also am getting rid of the native HDMI port. I might add a block for it later on if there is DisplayPort functionality, but as I've been looking at it, it looks really unlikely, especially over USB 2. And I also changed the USB-C port on top of the Ultimate port to a micro USB port just to make it cheaper in all overall cost. And yeah, if you are interested in any of these will be available on Academy, which will be available in the description, and also a GitHub link if you want to get it through there, which just makes it a bit easier for everyone. And on speaking of high quality aluminium products, this video is sponsored by JLC PCB. JLC PCB provides easy, affordable, and reliable PCB and PCBA solutions, empowering electronics engineers to develop projects efficiently. JLC PCB makes it just like you're shopping online on their really well-made website. Just add your own Gerber file and get a quote instantly. You have full customization over the material, component sourcing, stencil manufacturing, and high precision assembly all in one location. Get 1 to 8 PCB layers for only $2. These boards are extremely high quality and come in multiple different colors and standards. They also have a free PCB editor called EasyEDA. This is really good for beginners and what I used. You can also use their other services such as JLC 3D and JLC CNC. These services provide high quality anodose materials and high quality 3D printed materials. You can also use the community tab to see what other people like you have created. And right now you can save on their special 6-layer PCB savings. I wouldn't miss out on that. You also have lightning fast PCB turnaround time at 24 hours in most cases. For easy to use, affordable to make, and reliable PCBs, you can always count on JLC PCB. And I wasn't told to say this in the sponsor brief, but seriously, these people provide really good quality stuff and they know what they are doing. Visit the link in the description or pinned comment below. Now, back to the video. So it is now the 1st of June and I'm out of school. So now I'm going to be grinding so much and I will be making... It's now the end of June. I just spent all that time doing nothing. But anyway, on the good side of things, the original creator, Dave Hackins, has actually emailed me. Well, I emailed him first, but yeah, we were talking about it, and he said it thinks it's really cool, which is really, really shocking because this is a back garden project in my eyes. But yeah, I'm really happy with this, and I'm really happy to be able to kind of show and respect the original creator of this, because this isn't my design, remember that. So now, let's open our PCBs. So, here is our box of PCBs. Oh, this feels weird, because I got all these for free, thanks to JLC PCB. And in all seriousness, while I'm just opening this box, I will say, their services are actually really good. Like, this came pretty quick. This came within about 2 weeks, and that was from China, which is really good. Oh, Oh wow, this looks very weird to see in real life. Wow. Okay, okay. This is cool. This is perfect. Oh, and here are the little ones. Okay, I'm gonna open all these and show them on camera. Alright, and here are all the boards. They actually all sponsor a site. These things are so high quality. It's insane that I made these, well, designed them, but still. Yeah, if you need any PCBs, well, now you know where to get them. Make sure to check the link in the description. I'm only saying this for the people who actually watched the video, but you can get a really good coupon. So, as the months passed, I kind of just focused on other projects and videos, and I was kind of just putting off ordering all the parts. Not really, not doing anything, just clicking a button on AliExpress, but yeah. And then, when I got to doing it, it got delayed about 16 times. Now, it only managed to arrive like the first week in August because it just got delayed so many times by the time I'd actually ordered the replacement displays and stuff. It just was really long to get out on my original date. So what I did was I scrapped the entire project and started from scratch. I've also decided just to put the internal battery in the phone because it'd be such a hassle to realistically make a battery block because it's a proprietary connector that Samsung uses, and it's just far from my level. This whole project is a bit of an oversight anyway, and I'm doing way over what I expected for my level. So yeah, I'm not going to do the battery. And for the volume buttons, I've redesigned a little flex board that will just tap into the contact pins of the actual phone, wire into new buttons, and hopefully it'll work. And if I don't do that, I will probably just make like a mechanical button press into directly the buttons, which I might do. Started with the PCBs, and I actually meant to say, wait, didn't these PCBs that I just ordered look different? They were supposed to have micro USB connectors, and to that I say, yes. I actually got FPC connectors on them instead of micro USB, as it was just flatter and easier to wire through the phone, and it would just have made a lot more sense to use them instead of the likes of a micro USB port, as it just take up so much space in this phone that it'd just be unusable. So after a lot, and I mean a lot of fusion work, this was the final design. A fully working phone blocks. As you can see, I have holes for different sized M3 and M4 screws, which this is my most complicated project looking ever, which obviously beats the first NeoDisc thing, which looks really bad. And I also have modelled the back ports properly. They're all perpendicular to each other, and a little logo I put together in like 10 seconds on Photopea, which is the dodgy Photoshop. But anyway, it works. The model looks to work, and it measures out with the S10. Now, I did actually have to change the measurements of it because of the replacement display that I got was a bit thicker than the original one. So I did have to change that around, but I will be posting these models, like I said, online, but I'll be posting the original S10 ones online, because I doubt people will be using a replacement display. Everything arrived, and I finally had the chance to test it and see if it worked. As I plugged it in and set it up, everything just went and spiraled downwards. As you can see here, it says a USB charging device, which means it thought it was actually taking in power from the board instead of giving it out. So, what I had to do was ask my good friend ChatGPT how to fix this mess. And what it said was that the USB micro pins had to be shorted out on the ID pins, which I actually hadn't done. But I even just tested them with a pair of metal tweezers and it still didn't work. And I also decided to plug the board into the wall. And this is where everything went bad. The ribbon cable burnt. It went up in flames. Yeah. So basically, I had modeled the micro USB port into the ribbon cable connector wrong, and it was shorting out 5 volts and ground just enough to, well, burn. And the reason why it was coming up as a charging thing on the phone was as a over discharge protection feature, but it couldn't directly tell what it was. So it just guessed, really. And all hope was lost. The boards weren't working. My sponsorship deal had already finished by about 2 months, so I couldn't go back. Although I did have one more idea that I might get a tiny bit out of this project. Now, it's not anything near the original idea, but it's my only shot. So the plan was simple. Wire a USB-A connector to one of the pogo pins into the phone. Very janky, but I had only one last shot. Now I will still be using the micro USB pin, I'll show it on screen here, the little cable connector things. But even if this did work, I thought it wouldn't work when I put 2 blocks in, as the way I had designed it was all piggybacking off of the same blocks, and it would just short each other out and probably go up in flames. So as long as we have something working, I'm happy. Alright, so I've just finished soldering. I don't know if this is going to work, but I'll give it one chance. So USB into the adapter, that into there. Alright, this is the moment of truth. 3, 2, 1. Nothing. Nothing. Maybe my solder joints. Oh, wait, the lights are on the keyboard. Let's go! Let's go! It works. Okay, this project mightn't be fully dead. Although, even in my whole disappointment here, I did realize something that was actually pretty important. How difficult this was actually to make. I'm doing this on a simple USB connection level. I am 14. Anyone can do this. But to try and do this for a motherboard, CPU, processor, and everything really took Google a lot to do, and I don't blame them for cancelling it, as it was a really, really difficult idea that would be really great in thoughts, but really, really unexecutable for the time, and even now. So, these few days I have locked in. I've done so many models. As you can see here, I've been locked in. I've been trying to figure out the perfect model, and I figured out this. Basically the exact same frame, although with a 35mm box down. Now what this is, it actually houses the OTG connector just because it's a bit chunky, and then this panel wiring to the back, which I've edited again to have a small little inlet in it, so I can just wire the wires up properly into the back of the phone. And I'd say at this stage I will just have to glue everything in because I don't have time to actually screw them in and get it machined out of aluminium. So I'm just going to keep it done from PLA, but I will sand it down, hopefully. So even though this project seemed to kind of come to an end, I did figure out something to keep it at least going in thought. And I know this isn't even close to the original idea or whatever, but I really had to get this video out as it was supposed to come out near enough this day a month ago from when I'm recording this video, and it just wouldn't have made sense to keep going anyway. So I just decided to do this, and I know it wasn't great, but I mean, hey, I have a working phone. So I've put the phone back together fully now, and I'm getting some weird issues with the wireless charging coil. Basically, it keeps overheating, and I know it's that little chip on the wireless charging coil, but it's in properly. But it is in at a bit of an angle, so I'm going to try and fix that, and hopefully it'll boot, but I don't know, it's not looking good. So as you can see, I've added a magnet at the top, just so whenever I want to take this out and in, I can put this little 3D printed cap on, magnet it on, and then take it out. Now, is it anything close to the original idea? With battery blocks, Wi-Fi blocks? No. I'm not even going to do the N100 block just because it's unrealistic. But that's the thing. It's about turning expectations into reality and not making something, really. It's hard to describe, but I mean, I learned a lot with this. I learned how to make PCBs. I learned how to solder properly because all previous soldering attempts I've done have just been messy and I've burnt the solder. And long-term viewers will know that because of the Nintendo Switch incident. Now, I haven't actually made any blocks for it, but the phone works. And the reason why I didn't make any blocks for it is because I want you to comment down below what block I should make for this. What would you think if you were in my situation and had this one pogo pin phone? What would you want to put on the back of it? And why? And yeah, maybe if I like your suggestion enough, I'll make it and I'll obviously tag you in the video. But yeah, this is it. The phone works. So we're going to do a little montage of the phone. Even though this phone project didn't end out how I intended it, I still got something working, and that's a feat in itself. I thought this would go nowhere, and in comparison to my first project, the Neo disc, it looks 10 times better, even with the hot glue pouring out of it. But yeah, so as you may know, my next project is the Neo Metal Sonic, and I've been looking into it, and it's really difficult, but I'm still going to do it. And this is my last kind of time of giving myself the slack to use glue, because I really want to start using screws and properly countersinking stuff in Fusion, and just using it properly. And then, after that, or in between it, I have another project idea. The 4DS. Well, thank you for watching this, and, you know, even though this phone wasn't the real idea what it was, it still gives an image to Dave Hackins and Google for what they did try to make and how difficult it really is. Now, if you did like this video, liking, subscribing and sharing and doing all that, hyping it even, I don't think that's available though because I'm not in Eagle Land, but if you could do that, that would help a lot because, as I said, these videos are not cheap. So monetization would help me a lot and the quality of these videos would be much higher. And I just want to thank all of you for watching this video and have a good day.